Here we have the Visual Studio solution, and we're going to be talking about the code behind it in the main model and the whole process, the process as a whole of whenever the debugger is running inside of the experimental instance and what occurs in order for the method to be gathered and put into the syntax tree and processed, and then use of the SMT solver Z3 in order to process it. So what we have, if we start at the very beginning, whenever the user right clicks, actually before they even right click, what we have is we have some debug events that are set, that are initialized, and that whenever a context switch, or basically a break is seen, that breakpoint is processed. And as we can see here, there's different reasons why the breakpoint happens, but basically the main one is the runtime break mode. This is going to be our central loop. But before the process even starts and runs, what we have is when the user right clicks on a method and clicks the test code and clicks initialize, what happens is right click editor receives that callback. It finds the text in the editor, passes that text selection to the method inspector. The method inspector then initializes the constructor of that text, and then from there that method is processed. Here, that text is gathered from that text selection, and from within that method, basically it's just a while loop that gathers line by line and returns a string. That string is then sent to the syntax tree parser. Syntax tree is part of the Microsoft code analysis. If we just put them right here, Microsoft code analysis, C# provided by Microsoft, it provides a syntax tree parser, and it returns a syntax tree. Syntax tree has a number of different elements, types of different types in it. One of those types is a variable declaration. The other is an assignment expression. These two are very important because this gives the variables and the variable declarations. That will be used to find the local variables. That's what those two are important for. You see we've got some methods here. Load variables, get variables local. We go further into the process from the got the right click, and there's also the window part, as we saw in the last part. In the window part, the user process is to click initialize and then to click run. Each one of those is a command. So if we go to the command here, you see there's also a class variable here for the method inspector. That's passed over to the main model after it's processed. We just saw that method inspector, which contained the syntax tree. But if we go to the initialize, where's the, here we go, command initialize. So command initialize checks to make sure the method inspector's there, and it goes through and deletes all the breakpoints. And why that is there is just from a previous run. And then it sets a very important piece, which is the initial breakpoint. Initial breakpoint is signaling the beginning of a process. And so whenever processes run, what happens should start the debugger. Let's see. Here we go. It starts the debugger, and then when the debugger starts, it's going to hit that breakpoint. And what we have happen is the debug event is going to enter here. It's going to see a runtime break mode. It's going to get to this piece of code, which is a central loop. And that central loop, it's going to see that we've got our actions, which is our list of actions, is empty, and so a list of actions is going to be initialized, and then the first one's going to be processed, and then we're going to delete that breakpoint we just encountered. The same thing occurs on the else here, which at every breakpoint the action is going to be processed and deleted. Now, an action is composed of variables and breakpoints. Just get over to that. Posed a variable, a breakpoint, and a value to assign. Now, as I said earlier, the method inspector is going to give us some very important items. That's the variables, and it's also going to give us the location of assignment, because at those location of assignments or after and also before the comparison, we want to change the value of the variable. Most importantly, we want to change the value of the variable right before it's used in the comparison. If you remember, we had a method in the previous previous video where we had something like this. We had method, and we had int a equals 1 if a equals 0, and some kind of exception is thrown. Well, at this comparison, before this comparison occurs, we want to change the value of the variable a. So that is what I am referring to. So if we go back to load actions, before the variables can even be processed, we have to figure out where everything's at. We have to figure out where those. Oops, let me just go ahead and add that back in. We have to figure out where this. We know where the method is. We have to figure out where the declaration is. We have to figure out where the if statements are. And let's just kind of go through that. We're gonna have this thing called Z3 link, which is a link to the Z3 SMT solver along with some processing methods. We got the syntax tree, so we're going to go in there and we're going to look at that. So this is basically one big long loop. Got a for loop here for each loop. Take the root of the tree. Going to look over all the nodes inside the root. If it's a variable declaration syntax, we're going to process this as a variable. If it's an if statement, we're going to process this as an if statement. As you can see, this could get longer and longer. Right now, we only process if statements. There could be a lot other different types here processed here. And so if we look at the variable declaration syntax, what this does is it gives us the declared variables, of course. So we have the identifier, we have the variable name, and then we get the type. And from that, what we do, we create a constant. And we create a constant inside of Z3. Sorry, just had to grab something to drink there real quick. Throat was getting dry. We'll create a constant inside of Z3. And we've only got a few cases here defined as well. We got booleans, got integers. Basically, everything's been typed down to an integer for all these types. And we've got floats here. Single is basically a float inside of C#. We only handle one decimal case. So even within the floats, more and more things have been simplified. There's been quite a bit of simplification, because in order to handle absolutely everything in the world, it would have been just an enormous complex program. Would have taken quite a long time to build. So picked some very common examples for displays and processing purposes. So this gives us our variable declarations. I'm just going to go back a little bit. The very beginning, we have our initial for loop. So now that at each item, if it's a variable declaration, that's put into Z3. So let me actually go back over there. So that's put into Z3 because Z3 make constant, and we get our variables. Yep, variable to Z3, that's just a hash table. I'm just going to go back to the very beginning where we're at. So we process our declarations, and we process, not then, but as we see them, we process our if statements. Here's a little bit more complex, of course, because a if statement's a little bit more complex than a variable declaration, variable assignment, because we have a if statement, which includes a variable on the left and the right. And of course, the left and the rights can be more complex statements. It could be a call to a method. Right now, we're just using the simple layout where we have here where we have variable on the left and a constant on the right. That's all we're looking for right now, and this code reflects that. Even with that slight reflection, you can see that it's code gets a little bit long processing the case statements. We'll get more into that. So what we have is we have if statement. If statement has a type of expression syntax as defined by Microsoft Code Analysis, and what we get here is a binary expression. And from the binary expression, we get the left and the right. Right now, we're going to process the left-hand side, and from that, we get the identifier, and from that, we get the variable. So we've got the left side, which is the variable, and then we're going to go on to the right. And from the right, we're going to get the literal, which, look over here, we've got 0 as a literal. From the literal expression, we get the token for it, and we get the actual value. Then we look at the operator in between the two sides, the left and the right, and we've got defined equals, not equals, less than or equal, greater than or equal, and greater than. They all essentially work the same. I'm going to try to pick an easy one here. Let's see. Oh, we'll just go with the equal ones. Case equals, and some special code here if it's a floating point, but basically it takes the left and the right, and we just look here. Ignore this part here because this is just a special part for the floating point. It does some extra code for the floating point. And as you can see, just by adding the floating point expressions to the code, we've made it a little bit more complicated because each one of those has to be processed for each one of the different types of comparisons. But if we look here, we have the left and the right, and so we say tell Z3 make equal, and that gives us our expression, and we add that to a queue of solver assertions, which are then going to be used later on after we finish processing the tree so that we can solve. So for each if statement, we process this case statement, meaning that for each if statement in the method that we're currently analyzing, we process this case statement and can construct a set of solver assertions. Go back to the very beginning here. So this is our main loop. We've processed the variables. We processed the if statements. Let's go back up to the main model. Main model, we've processed the syntax tree. And then now that we process that, we're going to go ahead and say solve. And this is just basically a call on Z3. It's a call on Z3 to solve all of our assertions. So we create the solver, and we take each one of our solver assertions that are in the queue and process them in order. And for the solver, we add an assertion in it, and then we check it, and then we get the model, the Z3 model, which right here, right before the check, this says whether it's satisfiable or unsatisfiable, this check. I've never had one that wasn't satisfiable. I guess that's good. Again, we're dealing with the simple models. So we have the Z3 model here, and from that model, basically, we get the output of Z3. All this code here basically just drives the output, drives the values of the variables that are coming out. Essentially takes the value that Z3 model solves and gives us our constraints that we can put back into the local variables. Sorry, not the constraints. Gives us the values that we can put back into the runtime mode of Visual Studio as it's running through the debugger. Let me go back over here to our method actually. So we've solved the model in Z3. The Z3 has produced an output. It's produced an output for a variable. That variable is, in our case, A. And in this instance, what Z3 produces is that A needs to be 0 in order for this if statement to process. That's what the accumulation of all of the different pieces we were putting together inside of the Z3 link, grabbing at the very beginning, grabbing all the different variable declarations and if statements. We were constructing a set of equations inside of Z3 for it to solve, so that it can tell us what the value needs to be for our variable at that specific point in the code. Of course, this is all done, can all be done before the running of the environment that has this method in it that we're looking for. And what I mean by that is that there's nothing that changes that can change while this method is running. We know before it's running that A equals 1 here and that A equals 0 here. We can look at it right here on our screen. This does not change. It's by running the code that's not going to change. So in that regard, we can do a static analysis on it to figure out what those values need to be and run that through the solver during the static analysis. Well, we go back over to Z3. We got the solve. Main model solved it. It's produced our path variables values, and those variables, the values here, produced here, so that we have a list of variables and their values and where to assign them. We know where to assign them at because we have the variable declarations and assignments. Everything here was done by variable assignment locations. Again, it may have been better to do it at the comparison location rather than right after the assignment, but that was the choice that was made. So we produce from the variables and the breakpoints and the values that we need to assign, we produce an action that needs to occur. And that brings us back to our top level loop. We started off at the very beginning that deals with the breakpoints. Now, that's as a breakpoint is encountered, we flow through this loop. First breakpoint, as described, it starts off the actions. We initialize the actions, and we delete the previous breakpoint. It was set by the initialize button, and then after that, we process all of the actions here. So processing of the action consists of setting the variable's value and the next breakpoint. Setting the variable's value consists of finding the variable on the stack from the debugger and then also setting the actual value. So we have the variable from the debugger, and here we are setting the value of that debugger, and then we are setting the breakpoint of the next action. So as you can see here, we got the current action, current action, current action, current action, and we see here action versus the one that's being passed in. So that's for the next breakpoint, and basically it just processes as such. We've got a queue with actions in it. At every breakpoint, the next action is processed until the final one. That's it. Thank you.